Hold up, wait a minute. Ah, do, 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 ah. Okay. Hey there, my name is Alejandro. Welcome back for day 320 of me doing the Daily LeetCode challenge at the reach 1 year's worth of green contributions here on GitHub. Ooh, wait, I actually have like a year. Okay. Well, I'll keep going till I'm at 365. But otherwise, this is problem 320. This is for June 1st, 2025. Without further ado, let's get straight into it. Okay, today we got LeetCode Medium problem 2929. Ooh, it's like a, well, it's not a palindrome actually, but, or I don't know what the word is. Distribute candies among children too. Maybe we can bring this bar a little bit. Come on. Come on. Come on. Oh, come on. It won't let me. Oh, no. Okay. Okay, it won't let me. Alright, well, whatever. You're given two positive integers, n and limit. Return the total number of ways to distribute n candies among 3 children, so that no child gets more than limited candies. Oh, we've done something like this before, right? This is just like binary search or something. To distribute n candies among 3 children, such that no child gets more than limit candies. Oh, the total number of ways. Oh my gosh, okay. Okay. 3 children, right? Okay, n is equal to 5, limit is equal to 1, 2, 2, 1, 2, 2, 2, 1, right? So it's almost like, so it's like, for each child, oh, you gotta be careful here. Oh, this is an annoying counting problem, right? Well, it's the number of ways to distribute, right? I wonder if we can do this with like DP and candy left. Ooh, 35% acceptance rate. Ooh, and it's into the 6. Okay. Yeah. So we're probably gonna have to do this. We're gonna have to wait. Of course. What better way to start the month with some combinatorics, right? Okay. Because it's interesting. Because if you give one child 1, no. This helps. Yeah, if n divided by 3 is greater or equal to the limit, we're chilling, right? Or no. Then it's like num children, right? Okay, def dp self num children candy left. Assert num children 1. Num children equals 1. Return candy left. Right, cache. Right, otherwise 0. For amount in range 1, d left plus 1. Whereas plus or equal to self.dp num children minus 1 candy left minus amount return res, right? And return self.dp of 3 n self.limit equals limit can consume equals min of candy left self.limits can consume plus 1, right? Something like this. Wrong. 8. Interesting. Return can consume. Sorry. Still off, yeah? Wow. Actually, you can do 0 candy. That's also a thing. Okay, case 2 is good. This one we get 17. Why is that? 5 and limit is equal to 2. Is that what's going on? Nope. It's basically, yeah, it's like yeah, no, but that's literally the problem, right? It's like you want to put in each candy into the bucket, but each bucket has a certain limit, right? So it's like, once you filled up a bucket, right, one thing we could do is split this problem into two, right? One where it's like limit minus 1. Right, I think there's going to be some recursive aspect to this, right? But it's like, if the limit is 2, then you can set like, 1 is a hard limit. It's like, I can choose anything that's 1 or below. So then it's like, how many ways can I choose it, right? Then it's like, for each case, I need to do like, okay, let's say I put 1 as the limit, right? Oh no, but if I do 1, 1, 1, I gotta make sure that I have enough candy in the first place. Is there some constraint here? No, there's no constraint. Oh, that's so annoying on so many levels. Because there's just a bunch of if guards. Ugh. Among Children 3, can he left 5? Oh boy. Still no. Interesting. Can consume. Is this +1? Clearly not. 3 children. There's n candy left. Can consume for a single child is between how much candy left and the limit. If number of children is equal to 1, then like if one kid can only consume up to 2 candies, they can consume 0, 1, or 2. So it really should be can consume +1, right? Otherwise, for each amount in the range in which it can consume, including 0 up to that, then we should say, okay, what about the rest of the children? Number of ways to do the rest of the children. Oh, it's like you're starting to intertwine like cases where there's not enough candy, right? Yeah. Because if I did n is equal to 500, oh, actually that's, yeah. Yeah. Anyways, yeah, this just doesn't matter. Yeah, this problem is actually kind of annoying. Right, if there's 0, then there's 0 ways, right? Straight up. And this is command comma to run. Or 1. I don't know, this is weird. Yeah, 35% acceptance rate is actually kind of low. Well, maybe that's also a hint, right? Numbers where the sum is less than n. Oh, man, what an annoying problem, right? This feels like it's just like a probability trick, but it's like I'm like trying to think of the trick, but it's like the trick is like this exact problem, right? Like, ugh. It feels like one of those like fundamental skills like a statistician would do, like this, right? Ugh. So said no child gets more than limit candies. Bollocks, matey. Practicing that accent. We're gonna go to a board game night in about, it starts in about 40 minutes. We've been planning this for a month, where we're like all bringing food and so on, and we all have to do an accent. So I'm gonna do an English accent. We're like, oi, I think this person's a spy. They've been acting a little suspicious lately. They be talking to people they shouldn't be talking to, yeah? So that'll be fun. So in total number of ways to distribute any candies among 3 children, such that no child gets more than limit candies. You're hindered, right? Right, so let's bring test case, let's make this like that. Let's make the limit like that. There, right? No. Oh no, you have to distribute the end candy. This keeps tripping me up. Oh my gosh, this keeps tripping me up. I keep thinking this going the wrong way. So I have to distribute all end candies, right? So basically, like each child can gobble 2, like rom, 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 right? So there's basically 1 candy remaining. Each kid can consume 3 candies, like nom. So I have to give all the end candies. Right, and let's do 24 and 8, for example. Yeah. Check if there's too much candy to distribute. Or just enough. Exactly enough. Okay. Otherwise, there's enough. Right? Here we can just do if limit equal to 1, return 2. Free choose n, right? Let's do turn -1. Okay, that's good to know. Oh, it's just it's 0. What the hell? Dude, this keeps confusing me so bad. Yeah. At this point, you know that we can distribute and candy to 3 children. So let's compute how many ways we can do so. there's one way where they all consume 0. One. Yeah, I'm reading through every single possible case though, but this is what I should be doing. Right, I basically, no, I should basically be doing like, n, keep subtracting limits, right? And there's only 3 kids. So it's like, how many times can I basically subtract limit from n? Right? Until I get to a residue. Right, so limit times 3 is bigger than n. Reduce third length equals 3 lambda x equal y x times y r. Okay. Max of 0 comma this, right? Four. Yeah. Oh, no. I can give the first kid up to limit candy. Limit plus 1. What's going on?
Is this too much?
What is this? That's good? That's very good.
Holy shit.
So this thing, how am I gonna get 3?
Alejandro,
Oh, it's because I'm limited by
you know
what?
if I can just put the sauce in this since it's already hot?
Up, yes. Yeah, the point is that it heats it. But you want to give it a good mix. Agitation, I forget what all the different things, but like things that like increase the rate of reaction. The 2 most commonly known are like, temperature and agitation. Obviously, you're not gonna do stuff like pressure or like reduce a volume or anything like that. So just mix it a lot. But you won't need a microwave. This LeetCode is actually super annoying. It's super simple. Actually, you might be able to do something like this. But I keep thinking of this problem in the wrong way. It's actually hurting my brain. It's like, it should basically be, there's two options, right? I can either do one, or I can do two. Okay. Each kid. Candy. Hard at append. Length of range of 1. Min of limit, comma n. Something like that. Really now. 2 is 0, 0. Okay. Really, so now I don't get the 3. Oh, it's not gonna be that simple, right? It's like all dependent on each other. Oh, no. I just need to do this plus 1 to actually include it. Right. Basically, I have 2, 2, and 1 option, right? But then it becomes like, how many ways can I shuffle this, right?
What?
Or decompose this, basically.
Oh, I think I'm burning the meat. Yeah. Fuck.
Okay, since my friend and I have to go in like about 30 minutes, I'm gonna start looking at the hints, even though I definitely would want to struggle on this problem more, just because it's 5:31 p.m. and at 6 p.m. we have to be at an event and I still need a shower. I didn't even do a haircut yet, just because I wanted to do a LeetCode. But, so, you know what, without further ado, let's get straight into it with hint number 1. We can enumerate the number of candies of one particular child. Let it be I, which means I is there's to a limit of min and n. Yes, okay, suppose the second child gets j candies. Okay, so it's exactly how I was trying to solve it the very first time. Whoops. Once hit 4. What the absolute crap. Number of candies of one particular child, let it be I, which means 0 less or equal to I, less or equal to limit. Oh, the third child's amount of candies is fixed. Ah, so that's one thing I'm missing. When you fix the number of candies you give to the first 2 children, it hard-codes the number of children the third one gets. We have max 0. And the hard part is the fact that this must be done in linear time, not in square time, because there's 2 children, right? Yeah. see. Okay. So basically return is for I in range min comma n comma limit plus 1, and it'll be nice. Hell yeah. Yeah, okay, sweet. Let me just read. Suppose the second child gets j candies, then 0 is less or equal to j is less or equal to limit. Yeah, so first child gets square I less or equal to min limit comma add candies. Notice that when we pick number of candies for first and second child, call these I and j and C2 respectively, the third is left with n minus C1 minus C2 candies. It must be at n minus C1 minus C2 second child gets 0 less or equal to j less or equal to min of limit n minus I candies. Third child gets n minus C1 minus C2 candies. Fixed. So what we could say is thus for each amount of candy the first child can get, you can compute that there are this minus this plus 1 total number of candies the second child can get, where the third child is now irrelevant equation since number of candy it gets is fixed. So I bet you it's something like for I in range minimum limit comma n this minus 0 plus 1 minus 0 plus 1. Okay. Then for C1 let's just replace it with that. It's just the and we'll say res equals 0 is plus or equal to
Oh, should I put Parmesan?
return res. Yes. Okay.
I believe I didn't think
Did
of
I
that.
get this wrong? Oh, I could just say, I can just come back to the point of this. Actually, we have to actually account for the third child, right? To make sure there's enough. Right. It's not irrelevant, actually. It must be that the third child gets all the remaining candy. The third child only consume to limit number of candies. Must limit ourselves. This doesn't make sense. Limit +1. So basically here we can do C2 in range. With them n minus C1. 0 plus 1 equals n minus C1 minus C2. And suppose we go to remaining, let's go to limits. Right, so something like this works. Right, but is way too slow. That makes a lot of sense, right? So now how do we essentially get rid of this thing? It's gonna be one of those where we look at the middle, isn't it? Yeah. Or actually, I guess it doesn't really matter here, right? The three children kind of influence the others in the same way.
I'll put honey on the meat. What do you think?
Up to you. If the first child grabs C1 candies, then each of the next two children can only grab up to limit candies each, but it depends on the number of candies available. Okay, it's starting to get really late. We only have 15 minutes to get to that place. How much cooking do you have left? Because I still need a shower and everything, right? Okay, I'll just try to wrap up the video. Okay, let's see what they were saying. Min of limit of MISI minus max of this at +1. 0. Yeah. Makes sense. It's just I'm trying to understand the minus limit part here. Max of 0. N minus I. N minus C1. Yeah, minus limit for the third child. So it's like, basically the second child must consume at least this much. Okay. First child consumed C1 candy. Second child can consume up to limit amount of candy.
You gonna try this?
Limit, comma, n minus C1 amount of candy. Riquísimo. Is this did you do, what did you do to it? Did you put, because usually that tastes
I put
like
a little bit of honey on it. I put
Honey?
soy sauce. And I put sugar.
what? Brother,
I guess as long as you
what?
don't know.
It tastes the bell peppers. What the hell?
I guess as long as you don't
How do you,
know.
is it just that the Costco meat tastes better? Maybe that's why I like your meat so much. It's just the organic ground beef from Costco instead of...
So, I mean, I fucked up because I was cooking the spaghetti. But if you let the meat, like, the meat has a lot of grease, you let it cook. The grease comes out, cooks the meat comes out, cooks the meat, right? I mean, the grease comes out and cooks the meat, like the 17% fat. But at some point, it starts, like, cooking the carbs and it turns into sugar, and that's why it gets kind of sweet. But on top of that, I put a little bit of honey, a little bit of sugar, and it's like a little bit more sweet.
Interesting.
A little bit of pepper.
Okay.
We'll see. It looks like this. What do you think?
Then, third child has
I cut the peppers
Ooh.
into smaller pieces.
consumed remaining MIC1, MIC2 candy,
Vegans will not be happy.
but is limited by limit. Therefore, its limit candy able to eat. Hence, it depends how many the second child can choose not to consume, but still have child be able to consume all remaining candy. This is so confusing. This problem actually confuses me. Yeah. Damn, this problem actually confuses me. I keep thinking this in the reverse way. I need to like stop. It keeps confused. I keep thinking of like, I must add. Oh gosh, this is so annoying. Yeah, limit of n minus I, obviously. Yeah.
Maybe I put too much sauce in the spaghetti.
Second. This. So here we'll just do res plus or equal to this minus this plus 1. No. So what is going on here? Oh, am I dumb here? Should probably be max of 0 come out of this, right? Yeah, there we go. And submit. And there we go, bada bing, bada boom. Completion took 320 days. Consistency is key. See ya tomorrow. Okay. Nice. I mean, this is just an O of n solution. I don't know why people is so much faster. I guess they can just do it the one-line way, probably, right? Like, is this what's faster here? Not really. Or I guess they just don't use max and min that much, and that way it's just not that slow. Okay, no worries. Okay. Let it judge one last time. Really, okay, so nevertheless, as always on my videos, as a recruit recap of or solid problems. So for this one, I'm going to have to go rather fast because our board game night party starts in 7 minutes that we've been planning for a month, and it takes us about 30 to get there. I need a shower, so we're already super late. So the way that I saw this problem is by looking at the hints. This is honestly like kind of confusing to understand, but now I finally kind of understand the solution. Basically, you want to distribute n candies exactly amongst 3 children, where no child gets more than limit candies. Now, what I should preface is that you must give out all n candies, right? You can't have any candies spared. That was like the very first misconception that I had when solving this problem. You must actually get rid of all n candy. Okay, so that's statement number 1. You must get rid of all n candy. Now, this n candy that you have that you're trying to get rid of, you can only give it to 3 children, and each children will not accept anything more than limit. Okay, so if limit times 3 is less than n, you're screwed, right? Because you can give each kid at most limit number of candies, but you only have 3 children, so if limit times 3 is less than n, then you can't even give out all the n candies, so the answer is 0. You cannot, there are no ways to distribute the n candies among the 3 children, right? So you want to return the total number of ways you can distribute the n candies among the 3 children. So the way you did this is you realize, okay, since each child can only take up to limit number of candy, right? Then the first child can grab anything between 0 and limit number of candy, right? And note that for this problem, n is less than or equal to 10 to the 6, limit is less than or equal to 10 to the 6, means you must have a linear time solution. There's a very trivial n squared solution or even n cubed solution, but those are obviously kind of TLE. So here what you have to realize is like, okay, you're going to be able to at least do some kind of for loop, and what you're going to do the for loop over is the number of candy the first kid eats, because the first kid can eat either 0 candy, it can eat 1 candy, 2 candies, 3 candies, all the way up to limit number of candies, right? Or the minimum between n and limit, right? It's just that, you know, it can only consume up to limit, but obviously if n is smaller, then it can only consume up to n, right? So the first child can consume anything between 0 all the way up to a theoretical maximum of the minimum between n and limit, right? So that's why my code here, there's a bunch of comments, but the very first for loop, so res will be my return result. I'm at the beginning is 0 ways. And here I'll say for C1, so C1 represents the number of candy child 1 eats, right? So C1 can mean candy 1 or child 1, whichever one you care about. So for C1 in range, all the way up to the minimum between the limit and n, right? The limit is 0. No kid can eat more than limit, but if n happens to be smaller, then we do n. And then plus 1 to include the actual candy number itself, right? Because range, this will be from 0 all the way up to that number, and to include that number, we do a plus 1 here, right? I could get rid of the minus 0, but whatever. So then, yeah, here I wrote a lot of babble, but then the thing that you have to realize is like, okay, we're going to loop through every single possible scenario for the first child, right? Where C1 is equal to 0, meaning the first child eats 0 candies, where C1 is equal to 1, meaning the first child eats 1 candy, where C1 is equal to 2, 3, 4, all the way up to the minimum of limit and n, right? So we basically have C1, i.e. number of candy child 1 eats. Right? So that's basically what we have. Why? Because we're essentially going to do a for loop over every single possible combination of the number of candies that the first child can eat. So inside the for loop, we can basically assume that we have the number of candy child 1 has eaten, right? Because we're going to go through every single possible case and then add the number of ways for each of those possible cases and then return the result at the end, right? So now that we have C1, now let's think about it, right? The short answer basically is that the third child, right, can eat between okay, or let's talk about the second child. Let's talk about what is the theoretical maximum amount of candy that the second child can eat, right? How much candy can second child eat, i.e. C2? Here we'll say theoretical max will be what? Well, first of all, it can only eat up to limit candy. That's always a thing. But now we started with n candy, right? And the first child has already eaten C1 candy, right? So between limit and n minus C1, right, which is how much candy is remaining, or the number of candy, like, you know, a child is allowed to eat up to the maximum, we're going to take the minimum one of these two, right? And be like, okay, that is the theoretical maximum amount of candy the second child can eat, right? Obviously max of 0 in this, but in this case, since every single one is like, you know, up to this, it will never be the case that, like, you know, this is negative, right? So this is the theoretical max number of candy the second child can eat, right? Now let's also look at theoretical min. So the minimum number of candies the second child can eat, you'd be like, oh, okay, 0, right? It can just pick 0. Not so fast. If you pick 0 for the second child, right? Let's think about how much candy is remaining, right? There was n candy, right? There was n candy. Then the first child ate C1 number of candy. Now let's say the second child eats 0 candy. Then that's how many candies the third child must eat, right? Now remember, the third child is limited by limit, right? So if this number is greater than limit, this is too much candy for the third child to consume. It cannot, right? It's limited by limit, right? So it cannot consume this much candy if it's more than limit, right? So the theoretical min is actually not 0. It might actually be large enough. The second child has to eat enough candy, right? Such that it's like, you know, finally the case that, you know, the number of candy left for the third child to eat is less than or equal to the limit, right? So we have to account for that. So we gotta think, okay, it must be that n minus c1 minus c2, where c2 is the number of candy the second child eats, this thing that's remaining must be less than or equal to limit. So now we can solve for c2, which basically gives us n minus c1. We add c2 to both sides, subtract limit on both sides, so the limit is less than or equal to c2, right? So, and again, this is a theoretical minimum, so it'll be n minus c1 minus limit, right? Now this number could obviously be negative, so that's why here we do max of 0, comma this, right? But so again, that was just a little bit of algebra. And now, okay, we have the theoretical minimum, the theoretical maximum number of candy that the second child can eat. So, how many number of candies can the second child eat? Well, for each one of these, right, it doesn't break the bounds of what the third child can eat. So for every single value between the theoretical min and the theoretical max, right, the number of candy the third child eats will be fixed. So like, for example, if n is equal to 5 and limit is equal to 2, right, let's say the first child eats 0 candy, right? Oh, actually, that's a bad example. There's no such possible case. So let's say the first child eats 2 candies, right? So then there's 3 candies remaining. Then essentially, so I forgot where the train of thought I was going with this now. Essentially, the theoretical min and max was like yeah, if the first child eats 2 candy and the second child eats like 2 candy, for example, then the number of candy left is how much the last child must consume. So that value is fixed. There's no options for the third child, right? It's just one amount, right? If the first child eats 2 and the second child eats 1, then there's 2 candies left. The third child must consume all 2 remaining candies, right? So that's why we can say, okay, for each value in here, the number of candies the third child must eat is fixed, but at least we know it's valid, right? It's like at most limited and greater or equal to 0. So if the first child ate C1 candy, then the number of possibilities will be the total number of possibilities the second child can eat. So it'll be this value minus this value plus 1, right? If you want to find the length of a range of L to R, the way you do this is R minus L plus 1, right? So you just take this theoretical max, subtract by the theoretical min, and add plus 1, right? So that's why I do min of limit of n minus C1. Here I was just doing minus 0 to just really show that the second kid is eating 0 candy, right? It's like eating 0 candy, but it's not really necessary, so you know what, we'll just do that. I'll just get rid of the minus zeros that are kind of useless in here and there. There we go. So yeah, so I do min of limit of n minus min of limit of n min of limit in n minus c1, subtract by max of 0 n minus c1 minus limit, and then all plus 1, right? And that's what I add to res, because I'm going through every single possible number of candy the first kid can eat, from 0 all the way up to, you know, the minimum between limit and n plus 1, right? And then for each of those, it's like, okay, how many variations exist? Well, I compute the number of variations for the second child, knowing that for each one of those, the number of children candies the third child gets is fixed, right? And so I just add that to res, and then at the end I return result, and there we go. Bada bing, bada boom. We have a nice and working solution to this problem, albeit a little slow, but I'm guessing that people just did it because, like, you know, max and min are actually kind of expensive in Python. You can just probably like reduce the number of such calls and make it not max and min and so on, optimize it a little bit, and therefore get a fast solution. But I'm just not ultra bothered to do that regardless. So I'll just leave it as is for now. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and in shape or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.